Hello everyone, we are group 7 and this is our senior design project. We like to call our device FLOW, which is fluoride level observation in drinking water. Our device takes in a green 532 nanometer laser that goes through our cuvette, which our cuvette will emit orange emitted light, and this emitted light will go through and be detected by our photodiode, which will receive this light and input into our device a certain level of light intensity. And this light intensity will allow us to calculate our fluoride concentration. So now we will go into our testing and our calibration phase. So before we can calculate the fluoride concentration, we have to go through each sample and calibrate. So we will begin that now with our device.
All right, so once we connect through the app, we can, Alyssa's gonna place the sample in here, and from here, we'll just do a command, which is next, and it will record it.
So now on the display, we have, it's still in our calibration phase, we have our sample, and it'll store and record the values that it was done through our BLE connector app. And now it says place sample 0.10, which now we will place 0.10. Okay, now we're going to do 0.5. Okay, now we're going to go to 1 milligram per liter sample of our cuvette. And now we're going to take that value. Okay, now we're going to go to our 2 milligram per liter sample. Okay, now we have taken that value, we are going to go to our 5 milligram per liter sample. Awesome. Now we're going to go to our 7 milligram per liter sample. Okay, now we're going to go to our 8 milligram per liter sample. Great. Now we're going to go into our last sample, which is our 10 milligram per liter sample. Once this data is received, we will go into the calculation of our slope-intercept form, and we will be able to measure our data. Okay, great. So now we're in our measurement phase.
So through all of it, you can see that it says that the number 10 is in, and it says that it's detecting 10 milligram per liter
of fluoride concentration. So now we have calibrated. In our measurement phase, we are receiving that we are actually confirming that there is 10 milligram per liter of fluoride within our cuvette sample. So we'll try. Okay, so this is our 1 milligram per liter sample of fluoride, and it shows that there is 1 milligram per liter of fluoride concentration within our sample of cuvette. Okay, so this is our 5 milligram per liter sample, and it is showing that we have 5 milligrams of fluoride concentration. Okay, this is our 7 milligram per liter sample, and it is showing that we have 7 milligrams of fluoride concentration within our sample, and it's displaying on our screen. Okay, so now we have our 0.0 milligram per liter cuvette sample, which is our distilled water, which means that there is no fluoride concentration within our sample. And you can see here that this is our highest lux value because there is no fluoride concentration. And you can see that there is no fluoride concentration being red because it is a negative value.
So here we have all the library that are included. As you can see, we have the TFT-ESPI.H, which is for the display, the Adafruit sensor.H, and the Adafruit TSL 2591.H is for the sensor, and then our BLE, which stands for Bluetooth Low Energy libraries that we have here that will enable us to do any commands, all the commands that we have in the code on our app. So right here, these are the characteristics that we'll have. So this right here will determine the our device and what we can do to it, and based on the characteristics. All right. Here, this is the calibration variables that we have right here, and which shows us from all the samples that we have, which is 0 to 10, right here, and then right here is for the function to make sure that the sensor is operating at a high gain rate, and it will be at a 500 milliseconds, which is what we changed for more stability from 100 to 500 milliseconds. Our display right here is it shows out all our functions for the update display, which is all our colors, all the things that you see on our display right here. So it permits us to see all the function that we do and the colors that we've chosen. Here, this is our calculation for the slope that we did for the calibration based on our documentation. These are all the things that we had to calculate. All right, and this is for the process. So when we calibrate it, this will actually do the process for us and do the sample plus the non-concentration, and from there it will give us it will print the what we need to place and what sample we need to place based on the iteration that we have of each sample, which goes up to 10 milligrams per liter. And right here, and if it doesn't, it will just, it's an if statement for if it does, we don't receive any command, we restart the calibration. This is the measuring the lux. This is what we get from after the calibration and everything is done. We measure the lux based on the calibration stored data, and whatever sample we put in the device, it will give us the it will pick up which sample we have in the device. All right, and this is for to show the results of this is for another thing for the display. And this right here is very important. These are our command handlers. So if I press next, which we guys saw in the video, the beginning of the video, and we'll go to the next variable, next sample, until we can also do a reset command to make sure we go back to the first sample. Right here, this is a BLE setup. Just everything that we needed to do to make sure that this is the name of the BLE. We had to initialize it, and from there we are able to write. And the write function is what permits us to do the commands. And yeah, and then this is for the setup for Arduino, to let us know that it's ready and we're able to do our commands and work our code out. And this is the just Arduino loop to make sure that we keep after every sample we're able to do the next. And this is our delay, and this is our end of our code.
All right, for our specification, we have a compact device, lightweight. We have this 3D printed, and for our inside, we made sure that our sample over here gets excited by our 532 nanometer. That's one of the specifications that we mentioned.
Okay, so another one of the requirement specification was to design a PCB that will be central power distribution for all of the optical components. And here we went with a microcontroller, ESP32. And one of the main reasons why I'm choosing this microcontroller was also for another, on the software requirement specification, was to have a wireless Bluetooth connection that will be displayed on the portable device that we see here on the right. And right here we used a fluoride monitor Bluetooth application, and here we're able to control and manipulate the values. We input the values, and then we'll see the place samples with the display and get calibrated on the display device.